Hello, we're going to solve this problem together, but first, try it on your own. Alright, let's start by reading the problem. It says a water tank is in the shape of a right circular cylinder. So right away I want to just sketch this thing out to make sense of it. It's okay if it's a rough sketch, but I start with a circle on the top. And then I don't know the dimensions yet, but I'm just sketching it out to get a sense of it. Right, we have some kind of right circular cylinder. That's the cylinder tank. We'll draw a dotted line back here so we know it's behind, right? And even though it's a terrible sketch, it's my sketch and it helps me, right? And they tell us that the height is 20 feet, so I start labeling that right away. That's our height, right? From one circle to the other. The height is 20 feet. And that's all they tell us, right? They tell us the height is 20 and then the total volume is 320 pi cubic feet. And just remember, cubic feet literally means how many cubic feet could fit inside this cylinder, right? How many little cubes that are a foot in every dimension, foot by a foot by a foot, how many of them would fit inside if we filled it up? And it's saying 320 pi. Now pi is about 3, so 320 times 3 is about 900. This is about 960 cubic feet fit inside as the volume. But what we're solving here, they want to know what is the diameter. So how do I solve this? Well, I know the volume of a cylinder is equal to the area of a circle, pi times radius, or radius squared, and then times the height of the cylinder. So it's the area of a circle times the height. They give us the height. It's 20, so I'm going to substitute that value in, pi r squared times 20, and they give us the volume, which is 320 times pi. And I could write in my units here, cubic feet, but I'm just going to leave them out for now. So they want to solve for diameter, and I noticed there's no diameter here, right? There's a radius, but remember that if you take two radii, I think it's radii, and you add them up, you get one diameter. So we're going to solve for one radius and then essentially double it because two radiuses equals a diameter. Two radii, sorry. All right, so to solve for r here, I'm going to divide both sides by pi, get that scary constant out of the way. Scary but beautiful, of course. So pi divided by pi, that's just 1. They cancel out. And pi divided by pi is 1 over here, so we don't need to think about that. Right? And 320 equals r squared times 20. I want to know what r squared is. All right, so I'm going to divide now both sides by 20. Right? So these 20s cancel out, and then I have to figure out what's 320 divided by 20. Well, I know 20 goes into 105 times. There are 300s, so that's 15. And then another 20, so it's 16. So r squared equals 16. So what number squared is 16? Well, that's 4. Or you can think of taking the square root of both sides. Square root of r squared equals the square root of 16. And this means that the square root of 16, of course, is 4. We could say it's negative 4, but this is an actual physical object. And you can't have a radius of negative 4 because you can't have a distance of negative 4. Square root of r squared is r, right? So that's just another way of saying that the radius is 4. If we plug that back into our situation up here, 2 times 4, 2 radiuses equals our diameter, and our diameter is 8. And if you want to, you can check this. Plug in 8 for your diameter, recalculate, plug in 4 for the radius, square it, multiply by pi and 20, and you will get the volume, right? Anyway, the answer is 8. Thanks, hope this helped.